Let's look at 2024 AMC 10A problem 23. Integers a, b, and c satisfy ab plus 3 equals 100, bc plus a equals 87, and ca plus b equals 60. What is ab plus bc plus ca? Well, we have a system of equations here, and, well, we know that the solutions are integers, and that is really important for our problem, because if the solutions were not integers, this would be like a whole nother level of difficulty, or maybe this problem isn't even solvable. But in this case with integers, we can try and guess what a, b, and c are, right? So how do we do this then? Well, for integers, the best way to say, I guess, guess the number of solutions here, list out all the different solutions, is by prime factorization. So we need to get some equation represented by a, b, and c, or two variables from a, b, and c, or one variable, as in this times this equals, or maybe with more factors, equals some number here, some constant c. This can be 99, 999, -5, anything, constant. That is an integer. And then we can factorize this integer and then figure out the possible numbers for all these brackets and try everything out, which, yeah, shouldn't be that hard, I think, because there's only 3 variables. How do you do this then? Well, let's see. Well, I guess the most straightforward step you should think of here is like the moment you see the problem is, what if I just added all the 3 equations up? Because we want ab plus bc plus ca. So if we add all these equations up, we get ab plus bc plus ca at plus a plus b plus c. So all we have to do is figure out a, b, and c or something, and then subtract a, b, and c from the sum of these equations, which we know is a constant, which is 100 plus 87 plus 60, which is 247. So clearly then, I guess the way to factor this out is to add or subtract these equations from one another, because I guess that's the only thing you can do. What other option you have? Multiply these equations together? No thank you, right? That's the only option you're left with. So let's start by, I want to use adding here. So let's just add the first 2 equations, because, yeah, why not? Okay, so we have ab plus bc plus a plus c. We can factor b out, and we have b plus 1 times a plus c equals 187. Okay, so that is clearly what we want here. We want the product of 2 things equals or more equals a constant, and 187 is pretty easy to factorize. That's just 11 times 17. Straightforward. So this is either 187, 11, 17, 17, 11, 187, 1, or all the negative numbers here. -1, yeah, all of these. And then now we only have 8 cases to do. Okay, this might sound like a lot, but for problem 23, which is probably the hardest one, or one of the hardest problems in this test, which I don't think so, but okay, it should be. 8 cases isn't that much here, especially when they're all integers and you can just guess everything out. Okay, so firstly, b plus 1 equals 1. Then that means that b equals 0, right? Okay, a plus c is 187. Okay, so we know that a plus b plus c then would be 187. So ab plus bc plus ca, which is what we want, is the sum of all of these minus a plus b plus c. So that would be 247 minus 187, which is 60. Okay, that looks like that works, right? However, in this case, a, b, and c are integers. So are a and c actually integers or no? Right? How do you figure this out then? So I guess, well, we know b is 0, right? So this is just gone. So ca is actually 60. So if ca is 60, then c and a are both integers, then c and a are some factors of 60. But even if c is 1, a is 60, which is the largest sum you can get of c plus a, 1 plus 60 is still 61, which is clearly not 187, which is a plus c here. So I don't think that really works out when you actually think about it here and try to prove that this works. Okay, so then b plus 1 equals 11, b equals 10 then, right? And a plus c equals 17, so a plus b plus c equals 27. That means that AB plus BC plus CA equals 247 minus 27, which is 220. Okay, that again looks like that works, but how do we know if it works or not? Well, let's see. Okay, so we have, okay, what can we do here then? Oh yeah, so we have 10A plus C plus CA equals 220. And we can try out numbers for that, because we know A plus C is 17. So A plus C is 17, right? Well, if A plus C is 17, then, and we can try and, like, factor this out here. Like, we know that 10A plus 10C plus CA is 220, which means that A bracket C plus 10 plus 10C plus 100 equals 320. So A plus 10 times C plus 10 is 320. And then we can factor, like, we can try to factor this out and figure out what A and C might be. And also while maintaining the fact that A plus C is 17, but clearly it's not that possible here. Like, if you actually list everything out, I'll skip that part here. But just notice that if you list everything out, like 1, 320, okay, wait, list the most possible cases out that can make A plus C equals 17. So, okay, so things like, say, 20 times 16, right? That gives C is 6 and A is 10, which is 16, so not possible. And then if you look at more cases, you realize that, yeah, this just doesn't work. And also the fact that, the really simple fact that this is just not in the answer choices. Like, yeah, it's just not here. So this is, like, important in multiple choice questions. But if this were on, like, an exam that was multiple choice, then in this case you would have to prove it here. But right now, this is just not in our options. So, we didn't have to go through all that process of factoring for a second time. We could have just, like, ignored everything and, like, left this case. Okay, so wait, let me just erase everything. Okay, so moving on then. Here we have B is 16 and A plus B plus C is 16. So again, 27. So again, AB plus BC plus CA is 220, which is not on our answer choices, right? So, and then here, B is 186, A plus B plus C is 187, so AB plus BC plus CA is 60. Again, 60 isn't on our answer choice. So, moving on to negative numbers then. Let's hope this actually works. Okay, so here then, B is negative 2, right? And A plus B plus C then would be negative 189. So AB plus BC plus CA would be 247 minus negative 189, which is some number way bigger than our biggest option here. It's like 400 something or something or so. So that's not in our answer choices either. And then here B is negative 12, right? A plus B plus C is negative 17 plus negative 12, which is negative 29. So AB plus BC plus CA equals 247 plus 29, which is 270, 3. Oh, well, that's not on our answer choices either. Okay, I thought it would be, but okay. So now here B is negative 16. Wait, negative 18 actually. A plus B plus C is negative 29 again. Okay, yeah. And then, again, this is not on our answer choices. And then lastly then, B is negative 188. Yeah. And A plus B plus C then equals negative 189. So this is, again, not on our answer choices. So clearly something is wrong here because we've considered every case possible and this is not working out. And I think the most possible thing that could have went wrong was here. Maybe this was like 276. So, okay, negative 200, okay, wait, 247 plus 29 because it's minus negative 29. Okay, yeah, that is 276. So notice that when mistakes happen and you figure out that, like, okay, this question seems like it doesn't even have the right answer in the answer choices, then, like, Here you want to go back to the most possible case where you think you will have making a mistake and then redo that. So here, that was a simple addition mistake. Okay, so the answer here is clearly D then, because that's the only thing here we have on our list. So we don't even have to prove anything here. But if, say, like we had another case and the AB plus BC plus CA equals 284, since this is a single answer question, we would have to prove. So we'd have to actually solve for A, B, and C and see which one is actually an integer solution here. So thank you.